This is lesson 2.4, factoring x squared plus bx plus c. So now that we know how to common factor, we need to learn how to factor any trinomial of this form, x squared plus bx plus c. What this means is like b and c are just constants or coefficients. They're just any integer. So right here is an example of a trinomial that we might learn how to factor in this lesson. These trinomials, the main thing about them is that they have a coefficient of 1 with the x squared term, so it's always just the x squared term on its own. This makes it easier to factor, and we're just going to focus on those this year. Next year, you're going to learn how to factor trinomials that have a larger coefficient with the x squared term. So maybe there's a 5 or a 2 there. And there's actually in the Michelson 10 book in the 2.5 section if you want to get a preview of what you might do in grade 11. But for now, let's focus on learning this more basic version with the coefficient for the x squared term just being 1. So remember, polynomial factoring is the opposite of polynomial multiplication. We know how to do the multiplication. Now we want to basically do that in reverse. So for example, if we're given these two sets of brackets, we know how to multiply these using one of the 4 methods we learned. I use the FOIL method. And then we get this expanded trinomial here, x squared minus x minus 12. Factoring is doing these operations in reverse. So given an expanded polynomial, can we come up with the 2 sets of brackets that will multiply together to give that polynomial? So this, we're just going the opposite direction. I've listed out all the steps for factoring in detail with examples here. The first step, if they're not already in order, rewrite the trinomial in order of descending power. So put the x squared term first, then the x term, then the constant. So in this example here, we have our trinomial, but it's not in order, so I rewrote it with the descending order of power. The second step is you're always going to start your regular factoring by doing common factoring first. Remove any of the common factors if they exist. So in this example, they all have a common factor of -2. So I took out that -2, and then I left in brackets what would be left over if we divided every term by -2. Something to keep an eye out for is if your x squared term has a -1 in front of it, so let's say it's like -x squared plus 2x plus 3, let's say, that is still a common factor that you have to remove. When we're doing this form of factoring, the x squared has to be fully on its own. So we would have to factor out a -1, leaving us with x squared minus 2x minus 3 in that situation. Always take out any common factors. Next, you're going to draw 2 sets of brackets to be filled in. If there was a common factor, that just goes on the outside and we don't have to deal with it again. The first term in each of these brackets is going to be x every single time because those are the only factors of x squared. If we're thinking about doing this in reverse, doing our FOIL method, the first terms will be multiplied together, x times x. That would give you that x squared term. So that's what makes this form of factoring a little easier than the stuff you'll do next year because you only have one option for what goes first in each bracket. What goes next in each bracket is a little more complicated. You have to write a list of factors for your c term or the constant term. These are the possibilities for the remaining spots in the brackets because these 2 values will multiply to give you the constant term. So we're looking for this term times this term. Whatever those numbers are going to be, they have to multiply to give our c term or the constant that's on its own. So in this example, our constant is -20. And so we list out all the factors, making sure to have the ones with the correct signs. If it's -20, one of the values has to be positive, one has to be negative. So we've got 6 possible sets of factors. We're going to choose the factor pair that adds to your b term or the coefficient with x. So in this case, our coefficient with x is +1. So we need to find the pair of factors that adds to +1. And that would be this one here, -4 and 5. So those will be the values that you put in the remaining spots in the brackets. So we've got -4 and +5. It doesn't actually matter what order. I could have done +5, -4. That's okay. You get the same thing. So how can we check that we've done this correctly? We know that polynomial multiplication is the opposite of factoring, so we'll just do that to check. So we take the answer we just found and we use FOIL and distributive property to expand it out to check that we get our original polynomial. So I leave the -2 for now, and I use FOIL or any other method to expand out these brackets. I collect my like terms in the middle, 5x minus 4x, and then I use distributive property to bring this -2 into the brackets. And what do I get left with? This is my original polynomial, so I know that I've done it correctly. Let's go over a couple examples. So I've written most of this already, but I'll write the actual steps as we go. So first, we have to write this in order of descending power. That's already done. And then the second step would be remove any common factors. There's no common factors here. So I can go right to drawing my two sets of brackets that will be filled in. I know the first term in each will be x and x because those have to multiply to give me x squared. Then I need to get the remaining pieces of this bracket, or these brackets. So I list out the factors of my c term, which is -10 here. I've listed them down here, making sure to have the correct signs. And I had to pick the pair that adds to my b term, +3. So it works out that at -2 and +5, that adds to 3. So I know that will fill in the rest of my brackets. And that's all you have to do. You can either write, you don't have to do a check every time, but you can do a mental check. Like this would give me x squared plus 5x minus 2x, good. And these multiply to give me -10. I know I've done that correctly. B, so this looks a little different at first because we do have a coefficient larger than 1 with our x squared term. But remember, we always have to take out a common factor first. Once we do that, we'll be left with x squared on its own. So all of these terms are divisible by 5. That's our common factor. We take out a common factor of 5. We're left with 7x and 12. So now this is in a form we know how to work with. We leave our common factor out front and we can put our two sets of brackets with x in the first part of each. Then we list out the factors of our c term, in this case 12. There's a lot of them. And we had to find the pair that adds to +7, which is this one here. So we know our values will be +3 and +4. And then you're done. Some more examples. C here. First, we have to put this in order of descending power. We have to rearrange first. So x squared goes first, then the x squared goes next, and then the constant term on its own. There's no common factor to take out, so we can go right ahead with our double brackets and our x in the first part of each. We'll list the factors of our c term, which is 8. We've listed them all out here. And then find the ones that add to -6, which are these two. So it's going to be -2 and -4. This next example is a bit funny. Okay, it's in descending power. There's no common factor. So we start with our brackets. We start with x in both. And we'll list out the factors of c, +4 here. That's what I've done here. And then I need to pick the pair that adds to -2. But what you'll notice is that none of these pairs actually add to -2. So it's not, we haven't made a mistake here. It's just that this polynomial is not factorable. There's no value that we can put in here to make this work. So this is just done. There's nothing we can do. Cross it off. All you'd have to write here is that it is not factorable. I mean, if this happens, I'm not going to give you too many questions where this happens, so just double check that you're doing it correctly. But it is definitely possible, and there will be some questions in the workbook where they are not factorable. Two more examples here. For E, looks a bit larger because we have a bigger common factor to take out. So it's in order of descending power, but we've got an x to the 4 and an x to the 3. But they all at least have x squared in it. So we can take out x squared from everything. We can also take out -3 from everything. So once we take out that common factor, then we're left with something that's a lot easier to work with. We can leave that common factor out front, do our two sets of brackets, our x in the first part of each, and then we've got our factors down below. So what are the factors of 9, and which pair of that adds to 6? It would be 3 and 3. We write that out here. What's kind of new in this question is, if you notice, these two sets of brackets are identical. They're repeated brackets. So it's actually proper form to write your final answer as this, whatever that bracket is, squared, instead of writing it out repeated twice. So if your final answer ever has repeated brackets, put it as whatever that bracket is, squared. Our last question here, we've got some more than one variable, but it's the same idea. So we have an extra y here, but there's no common factor to take out. So I set up my two brackets. My x squared is the first term, so I'll just focus on that for now. I know that x will go in the first part of each bracket. But then I need to figure out my c term. What I've squared here, that is your c term. I know it's a little complicated because there's a variable with it, but just treat the whole thing as your c term. You can either list out the factors together, like what are the factors of 36y squared. I found it easier in my head to first list the factors of the coefficient and then list the factors of the variable. The factors of y squared is very straightforward. It's just y and y. Then I have all the factors of 36. There's a lot of those. I have to find the ones that add to negative 12, which are these ones here. So I have my negative 6 and my negative 6. So the only new thing in this case is that I also have a y with it. So you can essentially ignore that y squared and ignore the y here, figure out everything otherwise, and then just add the y's back in. And I'll show a check in a second of why I know this is right. Just like the last question, these brackets are repeated. So my final answer will be just one of the brackets and then squared, since they're the same thing. Because this question was a little more complicated, I did a check down here, got my answer, and then I'll expand it out to check that I've done it right. So we've got x squared minus 6xy minus 6xy plus 36y squared. When I collect my like terms, I've got my middle term of negative 12xy, which is what my original question was. So I know I've done this correctly. So this is our introduction to factoring of trinomials of the form x squared plus bx plus c. We know all the steps to solve it, and we know how to check our work.